In this video, I'm going to talk about how we can integrate this expression. Okay, so if you look at this expression, it's a product of two different functions. So the first thought that will come to my mind is, should I let this be dv and let this be u? Right, so let's try to let this be dv, right? Because liate, right? So if you recall, okay, so normally when we use integration by parts, right, we think about liate. Right, so L stands for logarithms and I stands for inverse trigo. And A stands for algebra or polynomials in general, and T is for trigo, and E is for exponential, right? So, well, we see e to the power of x cubed, right? So that kind of belongs to exponential, right? Or it seems. Okay, but anyway, let's try to let this be dv. Okay, and then we let the x to the power of 5 be u, right? Because, well, as a rule of thumb, we should let the one that is easier to integrate be dv. But then again, well, if you look at e to the power of x cubed, it doesn't really look like it's easy to integrate, right? Okay, in fact, I'm not too sure how to integrate e to the power of x cubed and express it as an elementary function, right? So, well, it doesn't have an elementary function. The entire derivative of e to the power of x cubed isn't an elementary function. Okay, so letting this be dv seems to be a bad idea. Okay, why not we switch? Okay, so let's switch, please. So maybe I should let x to the power of 5 be dv. Okay, and then we can let e to the power of x cubed be u. Okay, so let's see how this goes. Okay, then if I follow the by parts formula, this would be uv, right? So v would be a integral of x to the power of 5, right? So that's x to the power of 6 over 6, and this will be u, okay, minus integrate v du. So this will be x to the power of 6 over 6 and du, right? So if you differentiate u, you should get 3x squared e to the power of x cubed dx. Okay, so let's try to simplify this a little bit. This is half integrate x to the power of 8 e to the power of x cubed dx. Oh dear, now we have x to the power of 8. Should we do by parts again, right? So, by the same logic, we are not going to let e to the power of x cubed be dv. So perhaps we'll let x to the power of 8 be dv. Okay. And then we will let e to the power of x cubed be u again. But then this seems to be going nowhere. In fact, I think it's going to get very tedious, right? So, well, but let's just try it. Okay, maybe we might be able to get it. Okay, let's see. So this would be a uv, right? So integrate x to the power of 8, that's x to the power of 9 over 9, right? And this is ex cubed, right? uv minus integrate v du. So v would be x to the power of 9 over 9, and du would be 3x squared ex cubed. Oh dear, I think this is getting worse, right? I think we should think of something else. Okay, so if integration by parts doesn't work, then what else can we do? Okay, well, let's do a little bit of manipulation. Okay, so let's throw this working away, right? It's not going anywhere. Okay, so what if we were to rewrite this? Okay, let's see whether it helps. Okay, so I'm going to rewrite it as x cubed times x squared e to the power of x cubed. Okay, let's see if this works now. Okay, so, well, I'm going to treat this as one term. Okay. All right, so which one should we let be dv now? Okay, so we can actually do by parts, right? Like this. Okay, let's try to let this be dv then. Okay, so we'll let this be dv, and we're going to let this be u. Okay, so I'm going to do a side working. Okay, so how do we integrate x squared e to the power of x cubed? Okay, so if you notice, right, x squared is actually, kind of the derivative of x cubed, right? Except we are lacking the 3. So I'm going to introduce a 1/3 here, right? And the 3 here. Ah, okay. So the integral of this is basically 1/3 e to the power of x cubed, right? Okay, so let's keep that in mind. Okay. So what should this be then? Okay. Well, I'm still using by parts, and this is our u. So this is x cubed. And v being the integral of this, right? V being the integral of this is 1/3 e to the power of x cubed. Okay, so that will be our uv minus integral of v du. Right, so du would be 3x squared, and v is still 1/3 e power of x cubed. Okay, so this looks pretty good, right? It's much better than before. This is 1/3 x cubed e to the power of x cubed minus 3 times 1/3, no more. So this is x squared ex cubed. Okay, wow, this is going quite well, right? So we have already integrated the x squared times e to the power of x cubed, right? And that is 1/3 e to the power of x cubed. So this would be 1/3 x cubed ex cubed minus 1/3 e to the power of x cubed plus c, right? And then yes, yeah, this will be our integral. Okay, so hope this technique helps. Okay, so when you do integration, you can actually consider this strategy. Okay, so that's the end of the video. So please subscribe and like if you find it helpful. Thank you.